we'll talk about logical data organization, logical layout. We'll talk about databases and templates, about schemas and search paths, and about system catalog. When you initialize this new database cluster, PostgreSQL creates 3 databases. In our virtual machine, cluster is already initialized, and when you install package, say for Ubuntu, it initializes cluster for you automatically. But there is an utility which is called it is called initdb, and you can run it manually and create what is called database cluster. Cluster is a bad word. It has very many different meanings. Usually we call cluster several servers which connects to each other, but in Postgres, cluster is just several databases inside one database instance. So it is called database cluster. 3 databases, they have fixed names. First database is Postgres. This database is used for default connections. When you use Postgres operating system user, you connects to Postgres database. Then we have template 0 database and template 1 database. All 3 databases are initially absolutely identical. Template 0 must not change. In fact, it doesn't allow connection to it. Postgres needs this database in several cases. For example, when you want to create a new database with encoding, with different encoding, with encoding that is different from what you specify during initialization of your cluster, or it is using this database when you doing logical backups. So Postgres needs this database. And template 1 is a template database that can be changed, and every change that you made to this database is then copied by default when you create new database. When you create new database, it must be cloned from one of existing databases, and by default it is cloned from template 1 database. So in template 1 you can make all changes that you want to be propagated to all your databases that you will create. Okay. And of course you can create new databases as you want. Usually there is only one working database in database cluster, but you can use several databases if you want to. Inside database you have schemas. Schema is just a namespace for objects in database. It is used to logically group your objects. You can use schemas to prevent name conflicts between different applications that are installed into one database, and so on. In some databases, schema and database user is basically the same, for example, in Oracle. In Postgres it's not the case. Schemas and users are absolutely different concepts. There are some special schemas. We have public schema, and by default all objects are created in public schema. So if you don't know anything about schemas, you just work in public schema and it's okay. But you can create your own schemas. All system catalog objects, tables, are in pgCatalog schema. And there is another schema which is called information schema. This schema is documented in SQL standard. It represents system catalog tables as it's required by the standard. Also we have pgtemp schema. This schema is used for temporary tables and some other schemas as well. So if you have several schemas with objects, we need some way to specify in which schema we want to find our object, and this is done by search path. In this picture is shown a couple of databases. These are schemas, and inside schema there are some objects. pgCatalog is a schema for system catalog tables, and some system catalog tables cannot belong to a specific database. For example, pgdatabases table contains all databases in your database cluster. This table cannot belong to any specific database. It is global for all cluster. There are several global system catalog tables, and they are stored differently, and you just can query these tables from any database which you connected to. You can connect to Postgres, you can connect to another database, and you will see the same data because it is global objects. Yeah.
If I create a new database, it creates a cluster, or it creates a database?
It is created in your existing cluster. It's just another database in your cluster.
So what's the difference between the cluster and instance?
Cluster and instance is basically the same. Instance is usually data plus processes which use this data. So when you start up your Postgres, it is instance, it is working. And cluster is just data, just databases.
So when you create a new database, it creates inside the current cluster. It creates another database in the cluster.
Yes, exactly. You can explicitly specify schema name in object name. You can write schema dot name of your, say, table. For example, you can write select public.t star from public.t. Public is schema name and t is your table name. In this case, it's simple. You specified schema, so you know what you mean. Server know what you mean. But you can use unqualified name, just t. So Postgres must decide in which schema this object can be found. Postgres uses such path for it. It's basically the same as path variable in Unix and in Windows, which is used to find files. When you type command, path is used to path specifies directories in which to find this command. In Postgres, it is worked almost the same way. You can specify in this parameter search path names of schemas, and Postgres will try to find your object in these schemas from left to right. In first schema, when it finds your object, it will use it.
It's per database or per user?
You can specify this parameter on different levels, just like any other parameters. By default, it's global for all instances, but you can specify it at database level, for example, or for specific user, you can set this parameter. So you can specify search path differently. But search path parameter is just a list of schemas. Some of the schemas may not exist or maybe not accessible by this user. So actual search path may differ from this parameter, and we have current schemas function which can show you actual search path with unexisting schemas removed and with some schemas added to search path implicitly. There are two such schemas, pgtemp and pgCatalog, which are implicitly added to search path at first place, so that you can always query system catalog objects and your temporary tables. And first available schema, which you explicitly define in search path parameter, is used to create your objects. When you use create table, for example, table will be created in the first explicitly specified schema in search path. And about system catalog. System catalog contains description of everything which is inside your database. So it is information about database which is inside the database, so it's kind of meta information. Also, there are some views just for convenience. You can access these tables by normal SQL operators. You can select them. And also PSQL has several commands that can describe objects in convenient way. There are some conventions with system catalog. All tables belonging to system catalog starts with pg underscore. Then there are 3 letters prefix. These 3 letters are usually the first letters of object name. For example, not table name but column names. For example, in PG databases table, all columns starts with dot, which stands for database. All system catalog tables have primary keys, and this primary key is object identifier column. It is named OID. It is hidden by default, but you can type select OID and see this primary key. Another point, that object names are always stored in system catalog in lowercase. For example, if you create table T, in table PG tables, you will find it in lowercase t. Some other databases store in uppercase. But you always can use double quotes to quote any name you want, including lowercase characters, uppercase, spaces, and so on. And let's see. Here is a list of all databases in our cluster. We have 4 databases. Postgres and 2 template databases are standard, and another database named student is created in our virtual machine just to make it possible to connect by default to this database by student OS user. We can use \l command in PSQL, and it will show us the same list plus additional information. Owner of database, encoding, and so on. If you want to know what queries PSQL send to the server to execute this command, you can use this interesting feature. You can set echo hidden PSQL variable, and after that PSQL will show you queries. For example, I execute \l and PSQL outputs query which is sent to the server to get this list. By this method you can understand how system catalog is designed. Okay. What else? When you create new database, it is always created from an existing database, and by default it is using template 1 database. So we create database, we can connect to this database, and here we can see that we got another line for test database. Schemas, it is PG namespace table of system catalog. Here you can see some schemas. We told about public, PG catalog, information schema, and also here is some other schemas which we'll talk about later. Also, you can use \dn command. \d series of commands are used to describe. D stands for describe different objects. dn describe namespace. And you can get this list. Here you can see only non-internal schemas. So you can see only public schema. But you can use s modifier, dns command, to see all schemas, including system schemas. S stands for system. And this modifier you can add to different PSQL commands to get the list of predefined system objects, not only for namespaces. And another modifier is plus sign. Plus sign will show you a bit more information about an object. What kind of information depends on the type of object, but for example, dn shows you only name and owner. dn plus shows also access privileges and some description. Let's create our own schema, say special schema. Here we can see it in the list of schemas. And now we have two schemas, and how Postgres know in which schema to find the object. It uses search path. Default value of search path, which we can view by show command, is $user public. This construct $user means schema with the same name as the database user. So for student it means student, for Postgres it means Postgres, and so on. If there is no such schema, it just ignore it. For example, here we don't have student schema, so basically we'll be using only public schema. And function current schemas shows us actual search path. As you can see here, this schema is removed and pgCatalog schema is added in the first place. If I create some temporary object, pgTemp will be added to search path too.
If you create a table, where it will be created?
It will be created in the first explicitly specified schema to which you have access, so in public in this case. So let's create table. Create table T. List of all tables you can get by \dt command, and here you can see that table T is in public schema. We can get, for example, list of objects in some schema. We can use it by this query. pgClass is a somewhat main table of system catalog. It contains list of all tables, views, materialized views, indexes, and so on. And rel namespace is a foreign key to namespaces table. 3 first characters, it's just code of table, and namespace is just namespace. Here we can use such trick. We can write public and cast it to reg namespace data type. This cast gives us object identifier of namespace with name public. So we just get all tables with specified namespace. This is object identifier. We can do it another way. We can query pg namespace table to get object identifier of public namespace, and then use it in select from pg class. But this conversion saves us one table join. It is a bit simpler. We can move objects between schemas. Because schemas are just logical namespaces, it is very fast. Your data isn't physically moved, it's just a matter of changing some lines in system catalog. Alter table, set schema, moves one object from one schema to another schema. For example, table T, we set special schema to it. Now we cannot see any objects in public schema, but we can see our table in special schema. We can use such wildcards in object names to get list of objects which we need. So now we can write something like this. Select star from special.t. This is qualified name, so Postgres just find our table T in special schema. But if I write select star from T, it cannot find our table because special schema is not in search path. So it says that relation doesn't exist. You cannot find it. But we can change search path. For example, we can add special schema to search path, and then this command will succeed. Table T is in special schema. Postgres can find it now. When we use this command set, it set configuration parameter just for our current connection. It will be lost when we disconnect from server. But we can use other methods. For example, we can set this parameter on database level. Alter database, set search path equals to so on. After this command, any new connections to database will use this search path. To establish new connection, we can use \c command. It reconnects us to test database, and we can see that search path has the value that we specified in this command. Okay, you can drop unnecessary schema if it doesn't contain any objects. We have table T in special schema, that's why we cannot drop it. So we have to move our table to some other table space, or we can use cascade keyword. We can drop schema including all objects that are in this schema. This command will drop schema and also drop table T. Also, you can drop a database. It's not very common procedure, but we can do it. We must have no active connections to this database to drop it. So we can connect to some other database, for example Postgres, and then we can drop our database test. That's all. So, logically, we have a database cluster. Database cluster contains several databases, usually at least 3, but maybe more. Each database contains schemas, and schemas contain objects like tables and so on. To create database, you always clone another existing database, and by default it is template 1 database, and schema of objects is identified using search path. Any questions about databases, schemas, so on? Okay, let's do a practice. 20 minutes for practice, and then we'll move on to next topic.